Welcome to SAT Books. In this series, my goal is to help you get a perfect score in the SAT reading section. My name is Rifat Bari and I'm the founder of Math for Browns and a 99th percentile scorer on the SAT. I also got a perfect score on the math section. So today we're going to be diving deep into a book that's awesome if you want to pump up your nonfiction skills on the SAT reading section, and that's Energy and Civilization by Václav Smil. Now this is a great book if you want to understand the relationship between energy and civilization, and in fact it's been recommended by Bill Gates as one of his top books of the year. So let's dive right into it. Smil begins the book by saying that energy is the only type of universal currency. Not dollars, not pesos, not taka, but energy. Because to get anything done, one of the many forms of energy has to be converted into something useful. Smil says energy powers everything, from the rotation of giant galaxies to the terraforming of our own planet through plate tectonics that drives mountains up together and moves oceans, from the thermonuclear reactions that take place in our very own sun to the slow but steady erosion that erodes mountaintops like Mount Everest. Energy doesn't have to be explosive Instead, energy can be slow and steady. In fact, the Romans said a raindrop hollows a stone not by force but by slow and steady and continual dripping. We owe our very existence to energy. In fact, I wouldn't be here if plants didn't convert solar energy from the sun into biomass via photosynthesis. As Richard Adams once said, we can think thoughts wildly, but if we do not have the energy to convert them into action, they'll just remain thoughts. The evolution of the human species is directly connected with energy. In Fred, mathematician Alfred Lotka proposed the principle of maximum energy, which states that natural selection operates in such a way that humans, organisms, and other animals develop in such a way that they can transform the maximum amount of energy in the most efficient way. Need an example? Think about plants. Plants today are much better at photosynthesis than they were thousands of years ago. Energy is so critical to our survival that Wilhelm Oswald said, "Do not waste any energy. Make it useful." In fact, a direct application of this principle is agriculture, where wheat is grinded into flour, but then the remainder of the wheat plant is used as food for cattle and other farm animals. So you're not wasting any energy. You're making it useful. Howard Odum said that the availability of power sources determines the work activity in an area. So for example, if you have a tropical region like a rainforest, that's going to have a lot more work activity because a lot of the plant biomass can be converted into food or shelter or something else that's useful to humans. On the other hand, somewhere else like a desert that doesn't have too much energy that can be useful to humans is not going to have a lot of work activity. Anthropologist Leslie White says the degree of cultural development of a society or a civilization is directly tied to the amount of energy per capita that can be harnessed and put directly into work. Now, with all this blabbering about why energy is so useful to humans, you might be thinking, what is energy? Even though we don't have a precise definition for energy, we know the many forms that it can present itself in. For example, kinetic or potential or gravitational energy. One interesting fact is that we realized how to harness nuclear energy almost 20 years before we understood how photosynthesis works, around the 1950s. Let me show you a matrix consisting of all the possible types of energy transformations. For example, photosynthesis or accelerating charges are just two types of energy transformations. Now, here's the thing. No one type of energy is most important, kinetic or potential or gravitational. None of these are most important because we need all of them as a human species to survive. The sun itself is powered by fusion, which presents itself to the Earth in the form of electromagnetic light. Remember the electromagnetic spectrum? Yeah, that. Now, here's the thing. Not all of the sunlight reaches the Earth's surface. 30% of it is reflected by clouds, and another 20% is absorbed by the atmosphere. The remaining 50% of sunlight is absorbed by oceans and then later on sent out to space. Speaking of sunlight, what about photosynthesis? Well, it turns out plants can convert only 0.05% of sunlight into biomass, which is insane. That means there's a lot of energy coming from the sun, and plants are not too good at converting it into biomass or other forms of useful energy. Here's the thing, we're really lucky to be here on the Earth because the Earth is in what we call a Goldilocks zone. What that means is the Earth is just the right distance from the sun to be habitable for life. If the Earth was just 1% farther away from the sun, all of our water would be frozen in glaciers. And you know what that means? No water. If the Earth was just a bit closer to the sun, our runaway greenhouse effect would create intolerably high surface temperatures here on the Earth. Humans couldn't live on the Earth if it was just a bit closer. That's why we're so lucky, because we live in the Goldilocks zone. You might think, hey, we're just lucky to have an atmosphere that's habitable for life, but that's not the case. If the Earth was just a tad bit smaller, our atmosphere would run away. In fact, the Earth has to be sufficiently large for the gravitational pull to hold the atmosphere in place. After all, you don't want to end up like this guy, who lost his atmosphere a long time ago. His name is Mars, by the way. Smil ends the section by saying that we humans are a unique species in that we're the only type of animal to be able to harness and convert extrasomatic energies. That means we can convert energies outside of our own body. For example, other animals can't do that. Plants can only do photosynthesis inside of their own body. But we humans can convert and transform energy outside of our own body. A natural consequence of this is that humans are the only species to make tool making a distinguishing feature of our species. That's why you have simple tools like these: pulleys, levers, axles, all that good stuff. Folks, thanks for watching the first episode of SAT Books, in which we explored the first few ideas of Energy and Civilization, A History by Vaclav Smil. Hopefully this episode increased your nonfiction reading skills, but also gave you a few key ideas about how energy and civilization are interconnected. Thanks for watching, and in the next episode, we'll be checking out a few terminologies related to energy. We'll check you out next time. Thank you.